Alright, welcome back to another video on my channel, math_exe. Today we're going to look at more examples about angle geometry so far, which is about angles in parallel lines, special quadrilaterals, and polygons. So you can just check those videos out if you haven't understood that well yet. So let's just jump into it. So here, VWXY is a kite with WY parallel to XZ, and then we need to find the values of A and B as shown here. So angle A is angle VWY, and angle B is WXV. So this involves the properties of a kite, especially for its diagonals. So we're just going to look at this diagonal, and this diagonal actually bisects these angles right here. And what I mean by bisect these angles, I mean they divide, the diagonal divides these angles into two equal parts. So this angle right here must be equal to this angle marked in blue, as well as this angle. I've mentioned it in the past videos, so yeah. So using that property, we can just see that this angle right here is also 43 degrees. And fun fact, another property of a kite, it has two pairs of equal sides. So those pairs are these in green and these in yellow, like so. And first, I'm probably going to run out of space, so I'm just going to draw another diagram specifically for triangle VWY. And the angle WVY is that's 43 degrees plus 43 degrees, which is just 86 degrees. And keep in mind these angles are equal, and we need to find this angle A right here. Notice the triangle VWY is an isosceles triangle, therefore we can just find the value of angle A as shown. So 180 degrees, and keep in mind this is A. A is 180 degrees minus 86 degrees divided by 2. The top part will be 94 degrees over 2, which overall will be 47 degrees. Well, you can actually approach this in a different way by noticing the diagonals bisect each other in right angles, and that will give you the same result as well. So we found our first answer for A, which is A is 47 degrees, and we need to find B next. So notice WY is parallel to XZ, and I'm just going to draw the line segment for WYXZ, or actually I really don't need to draw it. I just can demonstrate it by myself. So notice that angle YXZ is angle YXZ and angle WXY are alternating angles in parallel lines. So you can just check them up pretty easily, and therefore they must be equal. And we know angle YXZ is 70 degrees, so that means this part is also 70 degrees. Alright, and since we know the diagonals bisect each other in right angles, we can just quickly confirm that this is a right angle. And we know that I'm just going to call this point O, since it doesn't show up in the diagram at first. So notice that triangle OXY is a right angle triangle, and therefore we can just calculate this green angle right there, which is just 20 degrees if you calculate that real quick. And by the property that I mentioned before, this diagonal, diagonal VX bisects this angle right here and this angle right here into two equal parts, and therefore since 20 degrees lies on the other part of this angle, that means B must be also equal to 20 degrees, since this is the diagonal bisects this angle into two equal parts. Alright, so that's the first question. Let's jump into the second one. Alright, for the second question, we have this polygon right here, and we need to find x. So we can use the sum of the interior angles in a n-sided polygon, which is n minus 2 times 180 degrees. And to find out what n is, we can just find the number of sides this polygon has. So we have 1, 2, 3, 4, 5, 6, and 7. So that means the total, the sum of all interior angles in this polygon must be equal to 900 degrees. And what I mean by sum of all interior angles, I mean the sum of each of these angles right here. So we can indeed form an equation in terms of x like so. So the sum of all angles right here, I'm not going to write the degrees out because you can just cross them out first. Make sure that I've written all of them. Yep, and this must be equal to 900 degrees. So you can just calculate this monstrosity out, and I'm just going to do this in a very quick way. So I'm just going to cut out when I'm done with this sum. Alright, so after calculating that sum, we arrive at this thing right here. So we can just subtract 720 from both sides to get 3x is equal to 180. That means x is 60. And this is our final answer. Alright, so that's it for the second question. Let's jump into the third question. It says each interior angles of a regular polygon is 5 times the size of each exterior angles in the same polygon. We need to find the number of sides the polygon has. So it's probably best to draw a diagram for this. So assume that these two sides are equal since it's a regular polygon, and these sides are the two sides of a n-sided polygon, and then we don't know the value of n yet. So we can just draw this. It says each interior angles of a regular polygon is 5 times. So what I mean by 5 times, that means we can just introduce a variable. So I'm just calling to this angle 5x degrees, and x could be anything as long as it is positive, since we don't want to deal about negative angles yet, and therefore this angle must be x degrees. And then if you come back to the original question, we didn't wrote incorrect information from this, and since the interior angle is supplementary with the exterior angle, we can just form another equation in terms of x, which is x so. And quickly solving this, we get x equals 30 degrees. So that means the exterior angle is 30 degrees and the interior angle is 150 degrees. I'm just going to write that real quick. Oops. Alright. So since it is a regular polygon, all of its exterior angles must be equal. And actually you can just use the formula for the size of each exterior angle in a regular polygon, which is as so. So 360 degrees over n. And since we know that each exterior angle is equal to 30 degrees, and here n is the number of sides the polygon has, which is what we're going to find right here, or I should say what we are needing to find. So from here we can just say that n must be equal to 12. So that means the polygon has 12 sides. Alright, so that's the third question. Alright, so here's the fourth question. So in the diagram below, AB is parallel to DF and CO is parallel to DE as shown here. And we know that BOE and FOC are straight lines. So we need to find the angle OED, which is this angle in yellow. So let's just focus on the first part, which is this one box in red. So it looks like we're not able to do anything because we have limited information. However, if we sketch another parallel line, which is parallel to AB and GF, passing through this point O, and we notice that there are some special angles. So for the first part, right here, box in green before, we know that by interior angles, this angle in blue must be equal to 50 degrees, since pairs of interior angles must add up to 180 degrees. And we can just do the same for this part right here, and we'll get this is 30 degrees. And from here we can just conclude that the whole thing of this angle right here must be equal to 80 degrees. And I'm just going to clear that out first. Alright. And since you know BOE and FOC are straight lines, we know that angle BOF, which is this angle right here, must be equal to angle COE, which is this angle right here, since they are vertically opposite angles. So we know this is also 80 degrees. And if we look at this segment right here in green, we know that by interior angles, our needed angle right here must be equal to 100 degrees, although it doesn't look like it because this drawing is inaccurate. So our needed angle, which is OED, must be equal to 100 degrees by interior angles, and they must sum up to 180 degrees. So that's the fourth question. Let's jump into the fifth one. Question 5. This figure shows a regular n-sided polygon marked in black, a regular hexagon marked in blue, and a square marked in red. And keep in mind this is not drawn to scale, as the square looks like a rectangle. And we need to find the value of n. In other words, we need to find how many sides the black polygon has. Alright, so first let's just work things out in the hexagon. So in the hexagon, since this is a regular hexagon, we can find the size of each interior angle in this hexagon, which is just 6 minus 2, and 6 resembles the number size a hexagon has, which is 6 of course, which is divided by 6, and calculating this you get 120 degrees. So each interior angles in this hexagon must be 120 degrees. And for the square, it's pretty obvious that each interior angles must be equal to 90 degrees. So that's a pretty common knowledge. So I'm just going to put this as a right angle. And since we know the sum of all angles at a point is 360 degrees, that means this rest of this angle right here must be equal to 360 degrees minus 120 degrees minus 90 degrees, which after we calculate this, you'll get 150 degrees. So this thing right here is 150 degrees. And from here we can just use the formula for the size of each interior angle in an untitled polygon. However, there's actually an easier way to do it, and that is by calculating the exterior angle in this polygon. So let's just draw a dashed line right here, and this is the exterior angle. And since this is a regular polygon, all interior angles and actually exterior angles and this polygon must be equal. So this bit right here is also equal to 150 degrees. And the exterior angle of this polygon is 30 degrees. And using the formula that the size of each interior angle in a n-sided polygon is 360 degrees over n. And since we know this is 30 degrees, we can just form this equation and then we can just solve for n, which is 12. So in fact, this polygon has 12 sides. Alright, so that's the fifth question. Let's jump into the sixth and final question. 6, this is a little bit tricky one. So first we need to find angle PDE, which is this angle, and DEF, which is this angle right here. And next we're going to show that AD is equal to CB later on. So let's just focus on the part A first. So notice by alternating angles, this angle, this 130 degrees angle, and this angle right there must sum up to 180 degrees. Since we know they are parallel, and we know that by these blue arrows right here. And from that we know that this angle must be equal to 50 degrees. And since we know DEC is an isosceles triangle, since we know DE is equal to EC, we know that this bit right here is equal to 50 degrees. And therefore we can just find angle PDE quite easily. So I'm just going to write the answer for part 1 of part A. So we know PDE is 130 degrees. Alright, for angle DEF, first we can just find this angle right here. And from here we can just find that angle DEC must be equal to 80 degrees, since all angles in a triangle must sum up to 180 degrees. And since the sum of all angles in a straight line is 180 degrees, and I should have mentioned that BCEF is a straight line as well as ADE. So that means angle DEF for the second answer is 100 degrees. So for part B, actually we need to kind of like do a little bit of work right here. So first we can just find angle ADC as well as angle BCD. So by the sum of all angles in a straight line is 180 degrees, you know that these angles are both 130 degrees. And since we know by interior angles in here and this segment right here, that means this angle must be equal to 50 degrees. And we can just do the same as well right here. Or probably before you find these angles on the bottom right here, you can just probably notice that angle ADC is equal to angle DCB, and thus therefore the legs of this trapezium and this is trapezium ABCD, the legs of these trapeziums must be equal. So we're done showing this. So I hope this is clear enough for you guys. So hopefully you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.